Okay, in this video I go over another type of normal distribution functions that you're going to need. And let's look at example 6.5 in the book, where we have a company who sells a product, and the product is normally distributed with a mean of 100 and a standard deviation of 10. So we know that it's 100 and a standard deviation of 10. But look what it's asking. It's asking how many of the product should be stocked so that there's only a 5% chance that the stock will run out. So they're not asking for a probability. They're asking for how many of these products should be stocked. So what they're asking is, what is this stocking level so that the value, the number that are sold, only happens 5% of the time. If you look at this normal distribution, we have something that's centered at 100, and they want to know what is the number stocked, this value on this horizontal axis, so that the area to the right is 5%. Well, we haven't solved that problem yet. We've used the norm dist to come up with these probabilities, but this number is given. This is the opposite. So how do we do that? Well, if I bring this spreadsheet over, there's two formulas that you need for the normal distribution. One is called norm dist, and what the norm dist gives you the value, a probability, which is the area to the left, given that you tell it what the x value is, you tell it the mean and the standard deviation, and your last argument is 1. However, if the area is given, then you use the norm inv function and you solve for x. So if it's asking for a value on this horizontal axis, if it's asking for a number, not a probability, but a number on this axis, and it gives you the probability, then use the norm inv function. So back to this problem, if I wanted to solve for what is this s of t, what I'm actually solving for is the area to the right. They're telling me that that's 5%. So to use the norm inv function, the area to the right is 5%. They want to know what should x be so that the stock out, the chance that you would run out. So that means you're going to stock more than the average. So how we'd solve for that would be equals the norm.inv. Now the first argument is a probability, but the probability that you have to give is the area to the left. So if we know the area to the right is 5%, then the area to the left is 95%, or 1 minus 0.05. You can say 0.95 if you wanted. Put in the mean, 100. The standard deviation was, I already forgot, 10. So that you should stock that many product. If you make that 116, that means that you would only run out 5% of the time. If we wanted to have a higher, what if we wanted to only run out 1% of the time? Then the area to the left would be 99, and you would stock more stuff. So you can see from an inventory standpoint, the further you are to the right, the less likely that you're going to run out. Now sometimes the problems don't ask for the area to the right, they give you the area to the left. So you have to understand the problem and know, are we working with the area to the right or the area to the left? And that would tell you if you wanted to either put 1 minus or just put in the area. Depends on what they're solving for. Okay. That should help you do problems 625, 630, 634. Thanks.